So if you look in section 4, the 2012, this is the rectilinear motion section. This one's a non-calculator, and if you see, it says from 0 to 12, a particle moves along the x-axis. The velocity of the particle is given by, and it gives you the velocity function, position at x equal -2 at t equals 0. So part A says from 0 to 12, when is the particle moving to the left? So remember, we know this, we get the velocity, set it equal to 0, do our sign chart, and where velocity is negative, it's moving to the left. Now this is a non-calculator, so we're going to set this equal to 0. So we're going to say to ourselves, where is cosine 0? Cosine 0 at pi over 2 and 3 pi over 2. So then remember, you got to take your angle, pi over 6t, equal to pi over 2. And if you multiply by 6 over pi, you get t equal 3. And then you're going to do the same thing, pi over 6t equal 3 pi over 2, and t equal 9. So we're going to come over here and do a sign chart, 3 and 9. And we've got 0 and 12. We should put the endpoints there. Now, and when you go to do a test value, you want to try to pick values that you can remember on the unit circle. And even if you can't remember the exact value, you're only interested in the sign. So from 0 to 3, I picked 1. So if I come over here, I'm talking about cosine pi over 6. So even if cosine pi over 6 really is the square root of 3 over 2, but let's say you didn't remember that. You do know cosine pi over 6 is in the first quadrant, so the x, which is cosine, is going to be what? Positive. Now, from 3 to 9, I picked a test value of 6, because if I put 6 for here, then I'm getting cosine of pi, something that I would know, which would be -1, so of course it's negative. And then my test value 9 to 12, really shouldn't pick 12, so let's pick maybe 10. So if we do 10 pi over 6, if you reduce that, that's going to be 5 pi over 3. So then, if you only remember the first quadrant, you can count. You got pi over 3, then 2 pi over 3, 3 pi over 3 is just going to be at pi, 4 pi over 3. So 5 pi over 3 is going to be in your fourth quadrant. So x is what? Positive. So where is it moving to the left? It's moving to the left from 3 to 9. So again, I want to reiterate, if it's on a non-calculator portion and you're thinking the unit circle, think more, even if you don't know the exact value, the quadrant it falls in, so you can know the signs. Now, part B says write but do not evaluate an integral expression that gives the total distance traveled by the particle from 0 equal to 6. Hopefully, if you don't remember this, you'll memorize this now. But distance is the integral of the absolute value of v of t. So 0 to 6, absolute value of v of t. You got 1 point for just writing that. Part C says find the acceleration of particle t. Is the speed of the particle increasing, decreasing, or neither? Explain your reasoning. Okay, so acceleration is going to be the first derivative of velocity. So the derivative of cosine is negative sine pi over 6t, and then we have to multiply it by the angle, so it'll be pi over 6. So this is our acceleration. Now remember, when you're talking about speed, speed is increasing if the velocity and acceleration have the same sign. So you're going to take velocity of 4, you're going to plug 4 in this, you're going to get cosine of 2 pi over 3. Again, if you'll just think where that quadrant is, that is going to be in the second quadrant, so cosine, which is x, is going to be negative. Acceleration of 4, and you're going to plug this in, you're going to get negative pi over 6 sine of 2 pi over 3. Well, sine in the second quadrant is positive, but then you're multiplying it by negative pi over 6, so it's going to be negative. So it's increasing because velocity and acceleration are both negative. Now, part D says find the position of the particle at t equal 4. So the position of the particle is where it starts plus 0 to 4 of v of t. Now, position does not have absolute value. If it's a distance, you would put absolute value of v of t. But position, so we started at -2 because they told us up the top, 0 to 4. Now, this is a non-calculator, so we got to do u substitution. So du will be pi over 6. So we're going to negate it by 6 over pi, cosine of u. So the integral of cosine is, and that should be positive sign, because the integral of cosine is positive. So it's sine of pi over 6 of t, 4 to 0. And so we got -2 plus 6 over pi. So we're going to put 4 in here. So we got 4 6t. That's going to be 2/3 pi. So 2 pi over 3. That's the second quadrant. So that should be positive. So it's going to be the second quadrant. And then minus 0. So you're going to end up getting -2 plus 3 pi over 3 over pi. Now, let's look at a 2011 one. This one you can use a calculator, and it says from 0 to 6, a particle is moving along the x-axis. The particle's position is not given. The velocity of the particle, they give us the velocity, and they give us acceleration, and x equals 0 equal 2. So that is the starting position. A, it says, is the speed of the particle increasing or decreasing at t equal 5.5? Give your reason. So remember, you got to see the sign of velocity and acceleration. And so this is a calculator active, so you can just look up 5.5 in the table and you get negative, and you look up 5.5, you get negative. So speed is increasing since both velocity and acceleration are negative. Now it says find the average velocity for the time period. Now remember, if it says rate of change, you're doing average rate of change, you're doing slope formula. But if it says average velocity for time period, you're doing 1 over b minus a, which is 1 over 6, 0 to 6 of b of t. And if you use Math 9, you get 1.949. So part C says find the total distance traveled from 0 to 6. So if you use integrals, you don't have to worry about where it changes direction. But you do have to put the absolute value. So you do 0, 6, absolute value of v of t, use Math 9, and it's 12.573. Now, part D says the particle changes direction exactly once. Find the position of the particle at that time. So you're going to set this equal to 0 and find the intersection in your calculator where it changes direction. So where it goes from positive to negative, negative to positive. So in this particular one, it only does it one place. It's 5.9. So to get your position, you start with your original plus 0 to that point, v of t. Now remember, position, you don't put the absolute value around it. And x of 0 is 2, and you go from there, do Math 9, and you get 14.135.